Good day, ladies and gentlemen. And if you did listen to my previous recording, this page must definitely be familiar to you. Now, we have highlighted in the previous recording um, some of the basics of the conversion. And we did mention in that previous recording the first example where we said that we have nominal and we have effective. And we said nominal is the advertised and effective is the interest that is actually earned. And we also highlighted also in the latter recording that nominal is equal to effective when the interest rate is compounded once a year. And we said that nominal is always less than effective whenever the interest rate is compounded more than once a year. And the more the number of compounds we have in a year, then the higher will be the effective interest rate. Or you can say the effective interest rate is greater than the nominal interest rate whenever the interest is compounded more than once a year. And we did say that in the first scenario, just change my ink, in the first scenario, that when the interest was compounded once a year, the advertised, which is the nominal, was the same as the effective. But when the interest was compounded more than once a year, which was half yearly, we saw that the advertised 6% was no longer the same as the effective interest rate that was earned, which became 6.09%. And I'm sure you're very clear with that. And we said now we need to be able to convert the interest rate from a given advertised nominal rate into the actual and effective interest rate. And we said that we do have a formula that can help us to do so. Previously, we were able to calculate the effective interest rate of 6.09% because we had all the numbers to do so. But now in the case where we don't have numbers to work with, but we only limited to the formula, that is the importance of the formula where now we can do the conversion. And I highlighted all the dynamics and the meaning of I and J and M in the latter recording. Now I want to delve straight to 3.8. 3.8 says calculate or compute the effective rate of interest. What are we calculating? I want to align this with the previous question. We are calculating 6.09%. In other words, I'm just using the previous scenario. We are proving, in other words, the 6.09. Calculate the effective rate of interest. Remember, I'm not doing the previous question. I'm just aligning this with the previous question. In other words, they require us to calculate that 6.09 rate of interest corresponding to the nominal rate of interest of 15%. Remember, previously the nominal was 6%. So now we are moving from 6%, which is the nominal, the advertised, and we are calculating the effective rate of interest that is earned. That is exactly what this question means. We are moving from the advertised nominal into the effective, which is the one that we have earned on the investment. Then now it says 15% per annum and interest is compounded how many times? That is where we're going. They say if interest is compounded annually, and we already know that if interest is compounded once a year, nominal is equal to effective, so there's no waste of time. We know that our effective rate of interest will be equal to 15%. Why that is the case? We have seen in the previous scenario that when the interest rate was compounded once a year, our nominal rate of interest was the same as the effective rate of interest. But when the interest rate was compounded more than once a year, we discovered that our nominal rate of interest was no longer the same with the effective rate of interest, because the interest was compounded more than once a year, which is half yearly, 2 times a year. Now our effective was more than the nominal. So now we also expect the same in the other scenarios, but not in the first scenario. In the first scenario, we know that our answer will give us the same 15% because the interest is compounded once a year. Now let me go and deal now with the question that we have. Now, although we know the answer will be 15%, let us just, for the sake of the requirement, and waste our time. But not waste of time, it's just broadening our understanding. Now we go further with that calculation. Just want to open my writing pad. Then we say the first scenario, they say if the interest is compounded once a year, meaning compounded annually. Then what are the formula says? The formula says to us 1, this is our A, 1 plus I equals 1 plus J. Remember, we were told that J is the nominal rate of interest. J is the nominal rate, which is the advertised rate of interest. And in this scenario, we know that is our 15%. That is our nominal rate of interest. And where is that J coming from? J is coming from the formula. There is J from the formula. There is our J. So we substitute over the equal sign, divide by m to the power of m. So remember, when you're using the formula, it must be 0.15. It must be in decimal, divide by 1 to the power of 1. So now this will be 1 plus I equals. Now there's no need for financial calculator. For this one, open brackets, 1 plus 0.15 divide by 1. Any number to the power of 1 will give you the same number. So this will be 1.15. So now it will be I equals, remember we have 1.15 minus, when this goes over the equal sign it becomes negative. So this becomes minus 1. Then our I will be equal to 15%, which is the effective rate of interest. Why is it 15%? Is because the interest is compounded once a year. So the nominal rate of interest will always be equal to the effective rate of interest whenever the interest is compounded once a year. So this was number 1 or number A. Then we go now to number B. Let us see what number B has in store for us. It is still the same formula, 1 plus I equals 1 plus 0.15. How often is the interest compounded in number B? They say let us calculate our effective rate of interest, assuming that our interest is compounded half yearly, meaning twice a year, and we know that it will be greater. Our effective will be greater than our nominal. So now it is twice a year, meaning our M is 2. Then we have 1 plus I divide by 2 here to the power of 2. Then that will be equal. Then now again I must use my calculator for calculations. How do I calculate now? Remember, I start calculating over the equal sign first. This is what I first have to deal with. I say open brackets, 1 plus 0.15 divide by 2. 2 indicating the number of compounds in a year, frequency of times in which the interest is compounded in a year, to the power of 2. Then that will give me 1.155625. Write all the decimals plus, don't clear your calculator. Then after, what is left now will be I equals 1.155625 minus 1. Now your calculator still has the answer, which is this answer in it. Then after, what do? You just say minus 1. Then after I set minus 1, you get your I being equal to, then it's very important to close brackets here so that you can say multiply by 100. So that your answer is already, after you have multiplied by 100, which is 15.5625%. So now this is your effective rate of interest that is accurate. Now our effective rate of interest, we can see now it is 15.56%, and it is more than the advertised rate, which is 15%. Why that is the case? Because our interest is compounded more than once a year. So now our effective rate of interest will be more than the nominal rate of interest. Now let us go to number C and see what number C has in store for us. Number C says that the same scenario does not change, but our interest now is compounded quarterly, meaning every 3 months, and the question is, how many 3 months do we have in a year? We have 4 3 months in a year. That means we have 4 quarters in a year. So now we're still calculating what? We are calculating the effective rate of interest, and we know that the effective rate of interest will be greater than the nominal rate of interest whenever the number of compounds are more than once a year. So that means this interest, we expect it to be greater than this interest, greater than this interest. Why? Because there are more quarters in a year than there are more 6 months in a year. And also we expect the last one, where they are daily compounds, that this will be more than this, more than this, more than that. So this will be the greatest effective rate of interest, because there are more days in a year than quarters in a year, and there are more quarters in a year than 6 months in a year, and there are more 6 months in a year than 1 year in a year. I hope that makes sense. Now we are in a quarterly compound. 1 plus I is equal to 1 plus 0.15 divided by 4 to the power of 4. 1 plus I equals, and again you first deal with this side of the equation, or of the equal sign. How do you deal with that side? You say open brackets, 1 plus 0.15 divided by 4. Remember, 4 indicates the number of compound in a year, which is 4 quarters. The interest is compounded quarterly, meaning 4 times in a year. Second function, deep 4, meaning to the power of 4. Then the answer you get will be 1.1586 50415. Then after, our I will be equal to 1.1586 minus 1. Don't forget here to put brackets and multiply by 100. Previously I forgot in the first one, but there will be no penalty for marks. Then after our I, then now that there's answer in your screen, in your calculator, don't clear, just say minus 1, because this is what you have in your calculator in the screen. Then you say minus 1. It saves you time to be rewriting everything. After I set minus 1, then after I'll say times by 100, minus 1 equals times by 100. Then after you get 15.86 5041% per annum. And we can see that this 15.86 is greater than 15.56, and 15.56 is greater than 15%. We can see that the effective interest rate is increasing as the number of compound in a year are increasing, meaning as more frequent the interest is compounded, the higher will be the effective rate in comparison with the nominal or the advertised rate of interest. Then now we go into the last scenario, which is number D. Let us see what number D has in store for us. Number D, they are telling us that let us calculate the effective rate of interest. We're calculating the effective rate of interest if the interest is compounded daily. If then the interest is compounded daily, how many days in a year? We have 365 days in a year. And the question is, what if it's 366? They will tell you, don't worry. Now we assume 365 normal year. Otherwise 366 is abnormal year. Then we have 1 plus I equals 1 plus 0.15 divided by 365 days in a year, or 365 compounds in a year, to the power of 365 compounds in a year. Remember, in this case, guys, we are assuming 1 year. we are not calculating for an investment for 10 years. We are assuming 1 year. That is the formula. So now we say 1 plus I equals. Then again, we just deal with this side of the formula. How do we deal with that side? We say open brackets 1 plus 0.15. Make sure that your interest is always in decimal whenever you use the formula. Divide by 365, close brackets, second function dip 365 equals. Remember, when I'm saying dip, I am in other words saying power to the power of 365. Then now the answer that I get in my calculator, it is 1.16117,984,984.43. Then now my I will be equal to 1.1617,984,43 minus 1. Then now our interest is equal to, again, don't forget to put your brackets in there, move the equal little bit, multiply this by 100. Now remember, in my screen of the calculator I have these numbers. So if I have these numbers in my screen, what do? I just say minus 1 instead of retyping. Then after, get equal sign times by 100. Then after, this gives me 16.17984431. I don't know how I missed this 31 before. There was 31 there. I'm sure you have identified it, that there was some missing calculation in there. So now this is percentage per annum. Now this is very important to highlight once again, in alignment with the theory that I read to you before, that the more times the interest is compounded in a year, the effective will be higher than the nominal rate of interest. And I explain that very much in details. And please also go through the theory and understand it in details. This is where that theory was coming from. And be mindful once again that we were doing the conversion. And I want to be very clear with the conversion, that we were converting nominal into effective. So this is the formula to convert nominal into effective rate of interest, because the next conversion, I will be now converting the nominal into nominal equivalent, which is from nominal to the same nominal but nominal equivalent. So now there's another formula that you also don't have to worry about how it is derived. But my next, before I do that formula, I'll first have to do this example of 3.9, where now we further do the conversion of nominal into effective. And you can see the note here, which is very important note before I close. It says, the more often is interest compounded, the higher the effective rate, even though the nominal rate is the same in each case. And exactly what I've been preaching, that the minute your interest is compounded more often than your effective rate of interest, or meaning the interest rate that is effective, which is end interest rate, will always be very higher than the nominal or the advertised rate of interest. And we have observed that in our calculations, that there are many days in a year, meaning it will be, the interest will be compounded 365 times, and the interest rate is 16 point, meaning it's more than 15%, which is the nominal rate. And we could see when the interest was compounded quarterly, that we got 15.86, and 15.86 is still higher than the nominal and the advertised rate, but it is less than when it's compounded every day. And again, when it's compounded half yearly, we could see that it is more than the nominal rate, but less than when it's compounded quarterly, and when it's compounded every day. So this is very lovely application of the theory, aligning it and applying it in real. Then it says now example 3.9, compute, what are we computing? The nominal and effective rate of interest. Now it's a bit different than the one that we were doing before. Before, what did we calculate? We calculated the effective rate of interest that correspond with the nominal rate of interest. Then the question now, how do we calculate the nominal and how do we calculate the effective rate of interest? And what do we mean in details when you say nominal? And what do we mean in details when you say effective? So now this is the next question that I will be unpacking to you. And in unpacking that question, I will have to bring your attention to this very important note that says the nominal rate is the rate that is used in calculating the periodic interest monthly, quarterly, half yearly, and on the investment. So now meaning the nominal will be quarterly, monthly, or half yearly, but the effective rate of interest is equivalent annual rate. And the fact that says annual rate, meaning we're looking at the annual rate of interest. But when it comes to normal, it can be monthly, it can be quarterly, it can be half yearly, but the effective, it will be an annual equivalent rate of interest. So now meaning in every scenario that we have here, we'll calculate either the monthly or the quarterly or the half yearly. Then the second part of the same question, we have to calculate effective, which is the annual rate of interest, meaning the interest for the full year. Then now that means in the case where our M is monthly, then we need to calculate the monthly rate. And remember, the minute is monthly rate, that will be nominal. The minute it is for the full year, that will be effective. And the minute is quarterly, we know that quarterly goes with the nominal rate of interest. So now I will be explaining this further, aligning the theory and applying this theory with the calculations. With that, guys, let me say thank you very much. You've been wonderful once again to listen and understand. Thank you.